Hey guys, so we will be doing 18 together on the study guide. So it says for the question that follows, there can be 4 equivalent best resonance structures of which of these? So it's for NO2, NO3, SO3, SO4, and BRO3. So if you look at the answer key, you know that it's going to be SO4 2 minus. So I'm going to show you why the other 4, those are incorrect, and then I'm going to show you why SO4 is correct. So let's get started. I'm fighting this glare. Does that help? Kinda? No. I'm just gonna wish for the best. I love overhead lights. Anyway, so NO2. How do we draw NO2? So you're gonna have N in the middle because it likes to form the most number of bonds. And then we're also because there's the least of it. Then we have O and O. So we can do this one of 2 ways. We can either do this actually we're gonna calculate the number of valence electrons. So how many valence electrons are in this? So it's NO2 minus. So there's going to be 5 plus oxygen has 6 times 2 plus 1. So it's going to be 18. So 2, 4, 6, 8, 10, 12, 14, 16, oh wait. 2, 4, 6, 8, 10, 12, 14, 16, 18. Now you might be wondering how I did this so fast. Partially because I did it beforehand. But also, nitrogen likes to form 3 bonds. Also, it's going to have be in brackets because it has that negative charge on it. Nitrogen likes to form 3 bonds. And when nitrogen forms 3 bonds, it's happy. It's going to have a formal charge of 0. We only want 1 formal charge, and this oxygen is going to have a formal charge of 0 because this oxygen likes to form 2. This oxygen, on the other hand, is missing 1. It likes to form 2 bonds, but it only formed 1, so it's going to have a formal charge of negative 1. We can prove this by using the formal charge formula. Fc equals number VE minus non-bonding or electrons, number of electrons not in a bond minus number of electrons in a bond over 2. It's kind of messy, but it's in your notes, so you got this, guys. If you can't read this, just look in your notes. You know what it's saying. So oxygen has 6 valence electrons minus number of electrons on a bond 1, 2, 3, 4, 5, 6. 6 plus, or actually this is plus right here. 2, because there's 2 in this one, over 1 over 2. So you're gonna get equals 6 minus 7. So you're gonna get negative 1. So this proves that this one's negative 1. If you did it with this one, formal charge with this one, it'd be 0. If you did it for nitrogen, it'd be 0. So that's what we get this negative 1 formal charge for. Now, you might be wondering how this has to do with resonance structures. Resonance structures is rewriting this element. The only resonance structure, valid resonance structure for this element is, or not element, for this Lewis structure is going to be this. I'm going to write it small. That's all you can really do to it. You can only really move this bond up here to get a different resonance structure. You can't do anything else. So there's only going to be 2 equivalent resonance structures for this one. So we know it's not NO2 minus because we're looking for 4 equivalent resonance structures. It can't possibly be that one, right? Right. You know I'm right because we have the answer key, and I just proved it. Anyway, so now let's move on to the next one is NO3 minus. So we're gonna have N right here. O, O, O. Let's calculate the as I fall. NO3 minus, so we're going to calculate the number of valence electrons. Number VE equals 5 plus 6 times 3 plus 1 because of that negative charge. So we're going to get 6 plus 18, so we're going to get 24 valence electrons. Yay, guys! So, let's start off. Oxygen likes to form 2 bonds, but nitrogen can only have up to, nitrogen can only have up to 4 bonds because after that it exceeds the octet rule, and if it's in that first row right there, if it's Li, Be, B, nitrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, or fluorine, these cannot break the octet rule. They don't have the proper d orbitals to break the octet rule. So if it's these, they must obey the octet rule. So this nitrogen can only have 4 bonds on it. So now let's add, because after that is more than 8. So now let's add our lovely little, these buds, because they have to have 8. And then afterwards, we can count to make sure we're right. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 20, 22, 24. 24. Cool. We're right. This is the correct structure. Now you might be wondering about formal charges. So as we discussed in the previous video, this nitrogen is going to have a +1 charge because it has 4 bonds and it likes to have 3. So you have a +1 charge. This oxygen, because it is 2, is going to have 0, -1, -1. So that's where this -1 comes from, plus, plus. These two are going to cancel out, so it's just left with this minus right there. Okay. LOL. So now we need to know how many equivalent resonance structures there are. So I'm going to draw the other ones down here, smaller, because I don't feel like taking up that much space. And since we know what this one looks like, we can draw the other two. I'm not going to draw all the dots because you know what the dots look like. So that's another resonance structure. And that's the other resonance structure. So that's only 3. You can't move this double bond anywhere else. So this can only have 3 equivalent resonance structures. So that means that it can't be this one because we're looking for one that has 4 equivalent resonance structures. Woo! On to the next one. SO3 2 minus. So now we need to see the number of valence electrons. So sulfur, it's not brilliant, so I have to look at the periodic table. 1 second. Oh, it has the same number of as oxygen. So it's going to be 6 plus 6 times 3 plus 2. We're adding the 2 for right there. So 6 times 3, 18. And that's going to be 8 plus 18. And that's going to equal 26 valence electrons. Woo! Yay, guys! I'm just so pumped. Anyway, so oxygen likes to form 2. It's going to have a charge of -1. So we're going to have these two oxygens be -1. And then sulfur is going to have this. And you might be saying, hey, Haley, that's breaking the octet rule. Well, since it's below the first line, the Li, E, F, N-E. You know the line. You know the line I did earlier. If it's below this line, you can break the octet rule by having this sulfur instead of, because usually sulfur would, sulfur's under oxygen. Oxygen likes to have 2 bonds, but sulfur, it can either like to have 2 bonds or it can give away all 6 of its bonds. So 2, 4, So this is 8. Now it's giving away 2 more of its bonds. I don't know if that makes sense. Hopefully it does. So that way you have 1, 2, 3, 4, 5, 6. It's giving, that's why it has 6 electrons on it. Anyway, hopefully that made some sense. And then you also do 2, 4, 6. I'm just going to erase this right here so I can 2 minus. So it's going to have a -1 charge on it. -1. It's going to have 0. It's going to have 0. Anyway, though, so once we draw this, you can see we can only have 2 other resonance structures. So, since it doesn't have all 4 resonance structures, since it only has 3 resonance structures, this is not the 4 resonance structures we're looking for, so it can't be SO3 2-, unfortunately. Hopefully my explanation of how it was drawn like this makes sense. Also, if you count the valence electrons. I'm just gonna erase these so that it's simple. 2, 4, 6, 8, 10, 12, 14, 16, 18, 22, 24, 26. That's correct. So 2, 4, 6, 8. Anyway, there we go. Next. Oh, also, shoot. Anyway, sorry, I'm setting up the next one. Yeah. Okay, cool. Anyway, so next we're gonna do, we know the answer to the next one is gonna be SO42-. So I'm gonna prove that BrO3 is wrong. So we get this nice little BrO3, right? And so we're gonna calculate the number of valence electrons. So Br has, pretty sure 7. Yeah. So 7 plus 3 times 6 plus 1. So we're gonna have 8 plus 3 times 8 plus 18. So we're gonna get 26 again. Woohoo! So we're gonna get Br in the middle. Yay us. Then we're gonna get oxygen, oxygen, oxygen. So, only one of these oxygen is going to have a minus charge on it because we only have 1 minus charge. And for elements like this, we usually want the middle one to be neutral. So we're also going to put there because Br is also below the line. So instead of Br can either make 1 bond or it can give away all 7 electrons. So 2, 4, 6, gosh, 1, 2, 3, 4, 5, 6, 7. So that's how it's giving. So I was using all 7 of its valence electrons. If this was fluorine, fluorine could only form 1 bond. But since this is not fluorine, this is bromine, and it's below the line on that table, it can do this. Anyway, if you count the valence electrons, you know this is going to be right. So 2, 4, 6, 7. Anyway, you can count them later. Also, this is going to have 0 formal charge, 0, 0, and it's going to get the -1, and that's where this negative comes from. Yay! And we want this element in the middle to be 0. Have a 0 formal charge, because that's just how it works. I can prove to you that it has 0 formal charge with this, so it's going to be 7 minus, use the formula from earlier, I'm not writing it again, 2 plus 2, 4, 6, 8, 2, 4, 6, 8, 10, so 5, 10 over 2, so we're going to get 7 minus 7, it's going to be 0. So that's how we know. Anyway, sorry, can't count sometimes. That's how this looks, but we run into the problem again, where it's only going to form 2 other resonance structures. So B, R, O, O, or O, O. So 1, 2, 3, 4, 1, or, sorry guys, my handwriting's atrocious. B, R, O, O, O. So this, once again, only forms 3 resonance structures. We're looking for one that forms 4 resonance structures, so it's not going to work out. So, we're down to our last one, which we know is the answer because we can look at the thing. So anyway, SO 2 minus. So we're going to have number of valence electrons. It's going to be 6 plus 6 times 4 plus 2. So 8 plus 24, 32. Pretty sure. I can do that in my head. I probably can. Anyway, S 0, 0, 0. It's not 0, but O. So we know that. So we know that this is going to have to be 2 minus. So we know that 2 of these oxygen are going to have only 1 bond. And with this, S is going to have 0, a 0 charge. So that's how it's looking. And so these two, this is 0, this is 0, this is 0, this is -1, this is -1. And that's how we get the, oh, I kind of wrote this kind of big. Shoot. I guess we're going to have to write the other one small over here. Anyway, that's how we get this. So now, we can make 3 other resonance structures with this. I'm going to write them really small. 1. 2. 3. Restructure 4. This is 4 equivalent resonance structures to this thing. Also, if you look at the thing, or not, you know what I mean, at the question, it's asking for something with 4 equivalent resonance structures. If you want a shortcut, how are any of those but SO4 2 minus going to form 4 other resonance structures where you move the bonds around if there aren't enough bonds to do that? So BrO3, there's not enough bonds. There's only 3 bonds. How are you going to change that 4 times? You're not. SO3 minus, there's 3 bonds. You're not going to change that 4 times. NO3 minus, there's 3 bonds. You're not going to change that 4 times. NO2 minus, there's 2 bonds. You're definitely not changing that 4 times. So, it has to be SO4 2 minus if you wanted a shortcut. But I also just proved to you how it's possible. Anyway, If you have any questions, just email me. I hope this was a good explanation. If not, leave hate comments. Oh my gosh, I'm trying to